Okay, so today we have Elise with us today. She's a current pre-med student at Harvard, and she actually created the Ultimate Ivy League Guide, which she's going to be telling you about as well. So I'll give it over to her and let her get started. Again, if you have questions, make sure you put them in the chat. And then she also has a bunch of socials you can follow as well, which I'm sure she'll be linking. And then we'll share those socials with you at the end of the session.
Okay. Hi guys. So my name is Elise Pham. I am currently a rising junior at Harvard University. I am studying molecular and cellular biology on a pre-med track, and then also my minor is global health and health policy, and then I'm also getting a language citation in Vietnamese. So that is essentially my academic profile. Outside of being a student at Harvard, I am the founder and CEO of Ultimate Ivy League Guide, which is a leading college admissions counseling program. So you can definitely check us out on our various socials. We are biggest on Instagram, where we have over 410,000 followers. We are also on TikTok, on YouTube as well. And then, yeah, I linked my socials here. So you can definitely search me up if you're interested in kind of like the help that I offer. And you can watch a lot of my free videos regarding like, how to get into an Ivy League and all of that. In addition to all of Ultimate Ivy League Guide and also being a student at Harvard, I also do cancer research as well. And I've had publications in various journals, including Harvard's undergraduate research journal. So I'll talk a little bit more about my journey. So yeah, with that being said, let's just go ahead and get started. I do want to begin by giving you guys a little bit more information about my overall journey with being a pre-med student at Harvard. So I wanted to first start off by, answering the most common question, which is why exactly is this your passion and where did it stem from? So to start off, the reason why I am interested in medicine is because whenever I was 9 years old, my mother had cancer and she had passed away whenever I was at a really young age. And so, because of this, I have always been very interested in medicine since then because it was that personal motivator for me. And I knew that I wanted to prevent other families from facing the same fate that my family did. And so, as I grew older throughout high school, I was engaged in various science activities. So, my school, I actually came from a pretty underprivileged high school. So, I didn't necessarily have access to a huge network. But even so, I was able to pursue research outside of school by cold emailing and trying to secure some internships. So I'll give you guys some tips over that during this presentation. And so, because of all of the science related extracurriculars I did in high school, I was able to get into Harvard University, where I'm currently majoring in molecular and cellular biology on a pre med track. In addition to that, this past summer, or last summer technically, so whenever my mother, before she passed away, she had received her most recent or her last chemo treatment at M.D. Anderson Cancer Center, which is a very popular cancer center in Houston, Texas. And so last summer, I was able to secure a job position at M.D. Anderson, and I worked there full time. And I actually ended up developing a or engineering a bio tool that can detect the onset of the exact oncogenic pathway that actually caused my mother's cancer. So it was really a full circle, and I'm really grateful to be in the place that I am now. And it's definitely something that continues to motivate me. And I am still doing a bunch of research as well during the school year. So yeah, you can see here on the right side, that's me at Harvard declaring my concentration in molecular and cellular biology. So that's a little bit about my background. And because I do specialize in college admissions, I do want to spend a bulk of this presentation giving you guys my insights on exactly how to like secure internships, how exactly to craft your overall college application. And this not only applies for undergrads, but also anyone who is a college student as well, this can also apply to you. And I'll also give you some tips regarding essays as well, because I know the college application process can be a little bit overwhelming for students. So hopefully this information can help you. So be ready to take notes because it is some valuable material. Okay, so let's go ahead with some future applicant advice. So let's talk about what is the misunderstanding whenever it comes to college admissions. So a lot of students think that college admission officers are evaluating you based on your past achievements. And while in a sense that may be true, that's not necessarily what they're focusing on. So admission officers focus not on reviewing past achievements, but on identifying your potential for future success. And so how exactly do you convey to admission officers that you have that potential to succeed at their university, right? That's basically what's going to make you stand out. So I'm going to give you two examples of a student that has been able to showcase their potential for future success and a student that has not been able to showcase their potential for future success. So you can kind of understand how exactly this works. So let's say, okay, for example, student A, they interned at a really popular athletic apparel company. They focus on the prestige of their internship rather than actually reflecting on the lessons they've learned and how exactly their experience has shaped their values and future aspirations. On the other hand, the second student, student B, while they didn't necessarily intern or gain any type of really, I guess, impressive extracurricular activity at a big company, they were able to still engage in an activity that aligned with their interests. And more importantly, they deeply reflected on their experiences whenever it came to their college application. So, what is the key takeaway here? It's really that whenever it does come to the college application process, it is extremely important for you to showcase your reflective abilities in your essays, in your interview, in essentially every component of your application. And that is going to help the admission officer understand that you have that potential for future success. So, again, how do you really showcase your potential for future success to the admission officer? So, first, academics, challenge yourself, right? So, take high level classes, whether that's AP courses, IB courses, honors courses, and pursue your passion. But high grades are the bare minimum. You do need to showcase intellectual curiosity and self improvement. And this can all be shown through your essays. And so I will go over my key essay framework later on in this presentation. So continue to watch and take notes, right? Make sure that you understand that it is important to showcase your intellectual curiosity throughout your application and your interview. This is literally something that they rate you on, and I know this because I pulled it right from my Harvard application. And then third, adopting a growth mindset. This is an extremely important thing to do, adopt a growth mindset because they want students that have that potential. Now, I want to go ahead and talk a little bit about internships and clinical experience as well, because a lot of you, of course, are really interested in the medicine path, but you're not exactly sure, right? You might be the type of student like, I'm really passionate about medicine, but I don't have a lot of experience. I don't know how to secure a research experience. How do I even go about this? I feel extremely overwhelmed. And so, if that is you, don't worry, I was in the exact same place as you. I remember being in 10th grade and just being extremely overwhelmed because I felt like everyone had all these opportunities, but I didn't know what to do. I didn't even know where to start. I knew that I was passionate, but I had no idea where to start. So, whenever it comes to internships, the truth is, university professors, so like, especially professors at top tier universities, they don't necessarily prioritize high school students. They'll mainly prioritize undergraduate students. So it will be a little bit harder to secure an internship with a university professor. Whenever it comes to securing internships and also shadowing experience or clinical experience, I would actually look at local startups or even at your local family clinic. So, my first volunteer experience, I had reached out to my family doctor and I just asked if I could volunteer. And so that was my first experience with volunteering, and it was something that I added on my college application as well. You can also use summer programs as a launching pad. So, a lot of the times, there is a bunch of medicine related summer programs out there that you can search up. There's some at Stanford, there's some at there's some at John Hopkins, there's some at UT Austin, etc. So there's many summer programs out there, and these applications they open in the fall/winter. So make sure that you look into this early so you can apply as early as possible. Whenever, if you do get into these summer programs, you can use it as a launching pad to secure an internship. So in these summer programs, you'll have the opportunity to network with professors, network with peers, and in this way, you can be able to secure an internship a lot easier, right? Just by cold emailing. So this is why I want to spend the next few slides talking about the strategy to cold emails. Whenever it comes to cold emailing your professors and also, just anyone in your local universities or local startups, etc. You don't want to just straight up ask for an internship because they're probably not going to give you an internship. So this is the cold email strategy that I recommend that students use. You can actually, like, if you want, you can screenshot this honestly and use it. So whenever it does come to cold emails, the first thing that you want to do is personalize the email. The second thing that you want to do is request a brief call. And the third thing is provide easier alternatives. Now, this will require a little bit more effort on your end. A lot of the times, what students do whenever they cold email professors is they'll personalize the email, but then they'll be like, can I have an internship, right? And a lot of the times the professor will not even answer their email. But if you want to really maximize your chances of getting a reply on an email, instead, what you can do is showcase that you are interested in what the professor is doing. So interested in their research, interested in their, clinical experience or their career, and then ask them like, hey, can I hop on a quick call with you, whether that's like a Zoom call or something, and ask you a few questions about your research or ask you a few questions about your career. This way, the professor or whoever you are cold emailing, they are more likely to respond to you because they're like, oh, this student is really passionate and they want to learn a little bit more about me. And everyone loves to talk about themselves. So, of course, they are probably going to be more likely to respond to you. So, request a brief call from them or request a brief call with them to move them to that second stage of really replying to you. And of course, because all of these professors and all of these physicians are busy, if a call is too much for them, also provide easier alternatives. So tell them that you understand their time is valuable. And if they can't hop on a call with you, you would really be happy to join any upcoming virtual meetings that they're having with their lab, or maybe if they're doing a public talk, you'd really like to participate in that, right? So providing them easier alternatives. So in that way, they'll try their best to help you, whether that is hopping on a call with you or providing you with the opportunity to join any virtual meetings they have coming up or any public talks that they're participating in. Now, that is the cold email to use. But of course, let's say that they respond to you and they're like, okay, great, let's, book a call for tomorrow at 3 p.m. What do you do during the call? So, what you do during that call with them is I would keep it like pretty short because their time is valuable. So, like, no more than 10 or 15 minutes, and ask sensitive questions about their career or about their work to really showcase your interest. So, ask about their day to day life, maybe what parts of their job they wish they knew before they really secured that position, etc. And then from there, what you do is by the end of the call, that's whenever you kind of pitch that question of like, hey, can I have an internship? Right. So at the end, then you ask for those incremental opportunities, which is like, hey, like, I really love what you're doing. Thank you so much for sharing all this information with me. If there's any position or there's any way for me to help you with your research, whether that's like shadowing you, whether that is doing something small on your team, please let me know. I would love to get more involved with what you're doing, etc. Right? So that is the way to really kind of cold email professors to maximize your chances of securing an internship. And of course, after the call too, make sure to send a follow up, be nice, tell them thank you, thank them for the time that they have given you. And even if all else fails, at least you were able to build your network. So I tried this technique on various professors, and some of them they didn't give me that internship position, but either way, I was able to reach out to them in the future and ask them to, refer me to other opportunities. Now let's talk about the actual college application process. So I know a lot of you guys are in high school and you're trying to think about how exactly do I prepare for college applications? It is so overwhelming. I don't even know where to start. I'm glad that you are in this meeting because I am a Forbes recognized college admissions counselor. You can search me up. And of course, I am the founder and CEO of Ultimate Ivy League Guide. And we are currently leading in terms of social media reach in comparison to other college admission programs out there. So we have a really comprehensive program. And of course, I'm going to reveal some of the advice that I want you guys to know regarding the college application process. So make sure to take some notes. Okay, in terms of crafting the application, the first thing that you want to do is develop a central theme. So, college admission officers, they're looking for well-rounded students with a value-based theme. And the reason why it is important to develop a theme is really think about it, right? If you're applying to all of these top colleges, especially Ivy Leagues, especially T20 schools, every single applicant, they're going to be very well qualified. They're going to have high grades, they're going to have many extracurriculars. So, how do you stand out? It all comes down to developing a central theme that ties all of your experiences together. Now, a lot of the times, the students have the misconception that, like, oh, I'm doing too many activities. I don't even have anything that relates my interests. Like, I'm too holistic. That's not necessarily true. Whenever it comes to a theme, it doesn't have to be an academic or an extracurricular theme in a sense. It really has to be a value-based theme. So, really, step one is identifying your core values. And here I put some examples of core values. You can choose any of these. There's obviously more than this, but whenever I did my college application process, I remember choosing some of my core values to be like responsibility, maturity, empathy, and community. So, like, I chose those were some of my core values, but honestly, any core value works as long as you reflect upon what your core values are. So, after you identify your core values, you want to choose a unifying theme to tie all of your experiences together. So, I'm going to give you an example right here. So, this is an extracurricular list from a student, right? So, they founded a club to explore eco friendly business solutions. They volunteered to modernize technology in their local library. They did a school event on social entrepreneurship. They did a recycling program. They made a really simple app, etc. So, how exactly can we tie all of these different experiences, different unique extracurriculars together? A core theme for this would be innovative leadership for social impact. Now, look at it. For the theme, notice how it is a value-based theme. I'm not just saying like their theme is technology, right? I'm really saying that their theme is a value-based theme. It is important to have a value-based theme so then whenever you begin approaching your essays, whether that's your personal statement or your supplemental essays, you can emphasize that value-based theme to admission officers and it's so much more clear the type of person that you are. Okay, and then step three, of course, once you have identified your core values and your value-based theme, you want to make sure that this is consistent across all of the application components. So activities and honor section, make sure that your value-based theme is evident. Your personal statement, supplemental essays, and letters of recommendation. So whenever it does come to your activities, for example, let's say you're describing your activities, if you know your values, then you could tailor your description of your activities in a way that highlights your values. So, for example, let's say that I am talking about, a shadowing experience and I want to highlight my value of community. In that case, I will really think about, all the times that I have interacted with patients, the relationships and close connections that I've formed with patients, and I'll highlight that. If you were trying to highlight your leadership value, but you're talking about your shadowing experience, then in that case, you would highlight the times where you have helped other shadowing interns learn how to talk to patients or things like that, right? So every time you talk about your activities, you really want to think about what value about myself do I want admission officers to know? And then again, making sure that your theme is evident in your personal statement, making sure that it is evident in your supplemental essays, and then also letters of recommendation. There is a strategic way to approach this as well, making sure that your teachers know what your theme is so then they can incorporate that in their letter of recommendation. Okay, now I want to talk about the key framework. So whenever it comes to especially supplemental essays, a lot of students, they don't exactly know how to approach a supplemental essay. And actually, I see that a really common mistake that students make is they'll just directly answer the prompts. So the prompt will be like, what do you pursue outside of school? And they'll just directly answer it. And if you do that, yes, you are answering the prompt, but you're not making your essay compelling in any way. And it is important that you make your essays compelling because admission officers, they're going through thousands of applications. And if they come across yet another non-original, non-compelling essay, they're not going to be excited about your profile at all. So making sure that you follow this key framework, which is the PPF framework, aka past, present, future. So this is how you tell a story in all of your essays. This is such a simple technique, but something that students get wrong. You want to make sure that in all of your supplemental essays, you have a past component, you have a present component, and you have a future component. Why is that, right? Remember in the beginning of the presentation, I said that admission officers, they look for your potential for future success. So that's why they want to see your growth. They're looking for your growth throughout your life. So then they know that whenever you go to their college, you're going to continue to grow. You're going to continue to reflect on your experiences. You're going to continue to learn the lessons you've learned in life. So I'm going to give you an example. So let's say we're tackling the extracurricular essay. So usually this will come in the form of like, what is something that drives, what is something that you're passionate about outside of your studies, or, how do you spend your time outside of school? So how exactly will you structure your extracurricular supplemental essay using the past, present, future framework? So this is how you would do it, right? So talk about how you became, let's say you chose an extracurricular, talk about how you became involved or passionate about the extracurricular. That's the past component. Then you talk about the initiatives you have taken on. So that's the present component. And then the future component is how you plan to continue this engagement or apply these skills. So, for example, let's say that I decide to talk about a shadowing experience for my extracurricular supplemental essay. So, the first thing that I would really talk about is why exactly am I interested in helping patients, right? Why exactly am I interested in medicine? So, that's whenever I will kind of brief over my background, which I noted earlier is, I became passionate about medicine and biology because my mother had passed away whenever I was younger because of cancer. And so that would be the past component, and that would showcase the admission officer why I'm passionate about this field. Second, the initiatives you have taken on. So if I'm talking about a shadowing experience, I'll talk about my role, right? I'll talk about my responsibilities. So what I do on a day-to-day basis, maybe incorporate some anecdotes of like times where I interacted with patients and how this all fulfilled me and how this really framed my future aspirations. And then finally, for the future component, how do you plan to continue this engagement or apply these skills? So if I'm talking about my shadowing experience, I could reflect upon like, because of this shadowing experience, I've been able to really understand the significance of ethical caregiving. And in the future, I want to pursue, you know, a career in the medical field. And in particular, I want to make sure that I really emphasize that value of empathy and that value of ethical caretaking in whatever endeavor I pursue. So that is how you really structure a supplemental essay to highlight your past, present, and future. And in that way, it makes a really like chronological storyline that is really compelling to the admission officer. And it's not just another essay where you're just bullet pointing a ton of things that you're doing in your extracurriculars. So yeah, make sure you remember the PPF framework, past, present, and future, and make sure that every single one of your college essays has that PPF framework in it. Okay, so this is essentially all of my social media handles. Feel free to connect with me. So I will say, like, definitely, if you have an Instagram, please follow me on Instagram. I post so many free advice every day. I post every day. So guys, look at all of my advice regarding college applications. I post a bunch of free guides on there as well. My YouTube is Ultimate Ivy League Guide. So if you take a look at my videos, I have a full 1 hour course on how to get into an Ivy League school. So definitely take a look at that. I also have a full course on college interviews. So I break down exactly how to answer the most common questions. I break down how exactly do you ask interviewers questions, etc. I have TikTok too, so I have two TikToks. This is my personal TikTok, and then this is the Ultimate Ivy League Guide TikTok. And then, of course, you can follow me on LinkedIn, where I will update regularly about my research publications, what I'm doing, etc. With that, that does bring us to the end of this presentation. So I'll actually go ahead and take any questions. If anyone has any questions about me, about my life at Harvard, about my research, feel free to comment in the chat box. I think that will probably be easiest for me so I can kind of read through some messages. So yeah, definitely, if you have any questions, put them in the chat. Okay. And for those who missed who I am, I can kind of introduce myself again. My name's Elise Pham. I am a pre-med student studying molecular and cellular biology at Harvard University. My minor my minor is global health and health policy. I am a Forbes recognized college admissions counselor. I'm the founder and CEO of Ultimate Ivy League Guide, which is leading in college admissions at the moment. And then I do research at Harvard Medical School and M.D. Anderson Cancer Center. Okay. So someone asked, let's see. So what would you recommend with regard to internships if you're a rising senior, since most of the internships and research deadlines have unfortunately passed? Yeah, if you're a rising senior and you're trying to look for a research opportunity, I would say probably cold emailing is your best bet. And emailing, whether that's like local clinics in your area, whether that's local hospitals or like smaller colleges as well, trying to find professors on their website. And I did show you that cold email template earlier on in this presentation, so you can definitely use that. Okay. So do you have any advice for rising seniors who'll be applying to college this fall? Yeah, definitely. If you haven't started on your personal statement, start on it. That is the most important thing. And if you can get that out of the way, you'll be well on your way to success in the college application process. For any rising senior that is interested in working with me as well, I have various students in my accelerator program, which basically I will walk you through the entire college admissions process. So I'll outline your personal statement. We will revise your personal statement multiple times. We'll revise your activities list. We will revise all of your supplemental essays. You get access to over like 500 hours of curriculum regarding the college application process. And then also you get personal meetings with me and 4 other Ivy League coaches as well. So that is the program that I essentially do. It's not only open to rising seniors, but also anyone in high school or under. So anyone who's trying to prepare for the college application process, whether it's like, oh, I need a passion project, but I don't know what is a compelling passion project to initiate. We also help with that as well. We also help with securing internships. We also help with crafting an overall theme for your profile. So if you are interested in working with me, you can probably go on Instagram and DM me coach. So you can learn a little bit more about how I can help you get into your dream school. But yeah, let me continue to answer questions as well. So let's see. Someone asked, how do you recommend we contact professors? So yeah, I went over that cold email template in this presentation earlier. So this meeting is like live streamed / recorded. So you can definitely take a look back on that. Let's see. Do we have to get a clinical experience if we want to apply to pre-med school? And how can we do it if there isn't support from local community? You don't need a clinical experience to get into a pre-med school. Again, a common misconception that students have is that admission officers are reviewing your past achievements, but that's not necessarily true, right? They are trying to identify your potential for future success. So as long as you really showcase to them how passionate you are, that's what really matters. And also, just to clarify, your entire application is evaluated based in the context of your area. So whenever it does come to the admissions process, it goes through the regional admission officer first. And because your regional admission officer is more aware of what opportunities are offered in your area, like if there's no clinical opportunities really offered in your area, they're not expecting you to have that clinical opportunity. But if you're going to like a school where there's a huge network, right, then they're going to expect you to have a little bit more high achieving extracurriculars. Okay. Um, what tips do you have for studying going into high school, college, and beyond? So yeah, at Harvard, I currently have a 4.0 as a pre-med student. And so my biggest tip whenever it does come to studying is priming. And what exactly does priming mean? So, whenever you go to class, a lot of the time students will walk into their class and they have no idea what lesson that their teacher is going to teach that day. And they have no idea what unit they're on and what they're going to learn. This is what you don't want to do. Priming means that you familiarize yourself with the class material before you walk into the class. And this doesn't mean like you have to like self-study and become an expert on the like today's lesson, but let's say your teacher posts like the PowerPoint slides before class, or they tell you like, okay, tomorrow we're going to learn about, I don't know, cellular respiration or something like that. Then what I would usually do is I would spend anywhere between like 5 to 15 minutes just at least like familiarizing myself with either the PowerPoint slides they post, or if they don't post PowerPoint slides, maybe I'll watch like a quick YouTube video over the same topic that they're going to teach me that day. That way, I have a general understanding of what I'm going to learn that day. And why is this important? Whenever you walk into class and your professor or teacher begins throwing a bunch of information and details at you, because you already have a general overview of what you're going to learn, what your brain will do is it'll automatically fill in the gaps with all of that like specific information that your teacher is giving you, right? If you walk into class and you don't have a general overview of what you're going to learn, whenever your teacher is just throwing information at you, you're going to like try to grab a bunch of different things and your brain won't retain all of that. But if you have a general idea of what you're learning that day, then it's a lot easier for your brain to remember it because what it does is it fills in the gaps of information. So yeah, definitely priming is like one of my favorite study techniques. Okay. Let me continue going about the questions. Okay. I'm going to try to choose questions that I think will help most people. Okay. Can international students use these methods to get into an Ivy League? Definitely they can. So yeah, everything I said, you can use that. I'm interested in medicine and I'm a rising junior, but some or most of my extracurricular activities don't reflect in STEM. Is this something I should be concerned about? No, you should be completely fine as long as you have passion in some type of way. Actually, I will be honest, like whenever it came to my college application, I actually didn't focus a lot of my interests on science, but I had like a few science slash medicine related extracurriculars, but I was actually really passionate about art in high school. So I did like art competitions. I made an art nonprofit and I just drew and painted a lot in my free time. And that's actually what I focused on whenever it came to my interviews, whenever it came to my application. And that is probably the spike about me that actually stood out to admission officers. So what I did was like I had a bunch of science and art interests and extracurriculars. But again, like I said before, you want to connect all of your experiences to a value-based theme. So my value-based theme really centered around my desire to help people. So whether that was like through arts or through science, I wanted to help people. So essentially having a value-based theme is probably the most important thing rather than, your if you're not in the place to like really tailor your extracurriculars at the moment. Okay. Um when you're applying for Ivy League schools, does it matter how many different colleges you apply for? No, it doesn't matter how many colleges you applied for. To be honest, I applied for like over 20 because I had a application fee waiver because I am from a lower income family. So definitely I applied to a bunch of colleges and I took advantage of that application fee waiver. Whenever it does come to the different application cycles, though, there is early action, there's early decision, there's regular decision, and there's rolling admission. So if you're applying to a school that has restrictive early action, that means you can only apply to that school for that restrictive early action deadline. So, for example, let's say you decide to apply to Stanford for restrictive early action. That means that you can't apply to any other private school with an early action plan um, as well. So, like, you can apply to like public schools that have like regular decision. You can apply to any public schools with like rolling admission, but restrictive early action means that you can only apply to one school. Okay. Um, So how would you recommend applying to colleges since most people use the Common App platform? Do you have a higher chance of admissions applying through the college's own website? So most students will apply through Common App or My Coalition, but some schools have a specific portal. So for example, MIT has their own portal. But I would say most students will apply to Common App through Common App or My Coalition. So what is the difference between Common App and Coalition? First, Common App has more partner schools. So more students will just use it just because they can find their schools a little bit easier on the Common App. Coalition is unique in the sense that it has a locker feature, which is essentially a feature where you can put, if you have any like art portfolios or any projects that you want to share with all the schools you're applying to, it has a locker feature. I will say, like, if you are looking for something a little bit more collaborative in a sense, or you have a mentor that's helping you, you can use My Coalition, but I would say most students use Common App since it seems to be an easier platform to navigate. I will say though, Common App, you can apply to a maximum of 20 schools. They allow you to add 20 schools to your college list, and also be very careful as well in terms of like what schools are you adding, because Common App abbreviates the schools on their college search. So make sure that you're adding the right school as well. Okay, so, okay, people are asking, how do you apply to my accelerator program? You can go on my website, www.ultimateivyleagueguide.com. You can DM me coach on my Instagram at Ultimate Ivy League Guide. You can, if you want to learn more about, like, if you want to learn the specifics of the college admissions process, I would actually go to my YouTube, watch my full course on how to get into an Ivy League. I also have a video over the personal statement as well. So I break down exactly how do you write the personal statement, and you also get to read my own personal statement example. So if you want to see what my personal statement looked like, the personal statement, I got no Ivy League rejections. So if you want to read that, you definitely can. Okay, let's see. I'm gonna try to get through some more questions here. Okay, does Harvard offer med scholarships? So Ivy Leagues, they only offer financial aid. So they actually don't offer like merit-based scholarships. All of these top schools, they will offer financial aid, but honestly, their financial aid is actually very generous. It's actually a lot cheaper for me to go to Harvard than it is to go to my state school. So like my sister, I'm based in Texas. So my sister is a freshman at UT Austin. She's paying like double what I'm paying to go to Harvard. So Harvard was very generous with my financial aid, which is something I'm extremely grateful for. Okay. Let's see. Does your guide offer help to get scholarships? Yes, we do. Okay. Is it true that we have to be naturally smart to get into an Ivy League, or can we work super hard and make it? You can definitely work super hard. I am not like I was not naturally smart in high school. The first SAT exam I took, I got a 1240, but I eventually studied and got it up to a 1580 because I kind of understood like how exactly College Board really breaks down their like how do they make their questions, right? There's a really strategic way College Board goes about making their questions. So if you actually know the exact strategies for how to tackle their questions, then it's a lot easier to get a really high score on the SAT. And yeah, for anyone that is interested in the accelerator program that I do, there is an SAT prep component to it. So I help students with the SAT as well. Okay. How to start creating a college list. Yeah, so if you're a rising senior, you need to finalize your college list as soon as possible. So whenever it does come to creating a college list, One tip that I have, and something that actually helped me throughout the entire college application process, was I basically created a document and began researching every single school that I wanted to apply to. And I began pulling out, unique programs about that school that I was really interested in, or I pulled out like professors I might want to work with, or I pulled out extracurricular activities I might want to join at those schools. So making sure that you have a mass document of all of the unique aspects of a school that really stand out to you. I would definitely look into a school's academic programs or how they approach their curriculum. So, for example, like Brown University, they have an open curriculum, right? Where they don't necessarily have core curriculum. On the other hand, Columbia has a core curriculum, so they're a little bit more structured than Brown is. So it just depends on your preferences. But essentially, have a mass document where you're researching every single school you're applying to, because this document will not only help you whenever it comes to your Why Us supplemental essays, but whenever it comes to your interviews and your interviewer asks you like why did you apply to the school, you can tell them exactly why because you did your research already. So definitely, if you are a rising senior, that is one tip I have. Okay. Can undergraduate students use your tips to apply to medical school? Yes, you can. Definitely, all of this applies as well. How do you craft being a valedictorian in a unique way? I was also valedictorian at my high school as well. I wouldn't really try to emphasize that in your essays really at all, just because that will already be clear through your resume. So if you like really just try to like tell them that you're a valedictorian, I don't think that will come off too well. And just FYI, Ivy League schools and all these top schools, they reject thousands of valedictorians every year. So they're looking for more than just your academic accolades. Okay. Um, Unrelated to college admissions tips, was there anything that you yourself as a student have regretted or want to redo? That depends. I would say I think in high school, I wish I thought about the college application process a lot earlier because I think that would have helped me a lot more. So, like, if you're a freshman, if you're a sophomore, a junior in high school right now, this is like the perfect time to think about passion projects, right? And whenever it comes to passion project, making a unique passion project, you need to intersect your academic or extracurricular passion with a desire for community service. So intersect those things and then find a unique approach to solve the community issue that relates to your interest. So that's how you really initiate a passion project. So I think that's one thing that I wish I did in high school a little bit earlier. In terms of college, what I wish or I wanted to redo is definitely, I think, before my freshman year. I think I wish I reflected a little bit more on like the type of community that I wanted to surround myself with and also my core values as well. So then whenever it came to like navigating friendships and community in college, I could be a little bit more intentional about that. So I would say those are probably my regrets. Do you have any time management advice? Oh, this is such a good question. So yeah, whenever it comes to time management, I will say, like, I not only create a daily to-do list every day, but I also create a weekly to-do list. So every week, I kind of plan out like what are the larger tasks that I want to get done, and I list my tasks based on their priority. So I list them based on like the urgency and also how important they are, and that really determines the priority of the task. And then in addition to that, um, every night I also go over I kind of outline what my next day will look like so I can make sure that it is as productive as possible. So for me, like, I wake up pretty early. I'll I think about okay, actually, let me give you an advice. I would do something that I term strategic prioritization, which is essentially every day or every week, think about what are your main priorities, right? And of course, you're not going to be able to prioritize everything that's important to you every day. So, for example, like the main priorities in my life, I would say, like, okay, academics, business, health, friends, right? So friends, self-care, I guess. So those are like the main priorities of my life. So let's say that my friend wants to hang out with me tomorrow. That means that tomorrow I'm going to prioritize hanging out with my friends. So I'm prioritizing that social aspect. So that means that today I'll probably need to prioritize other aspects or like other things that are important to me. So whether that's like my business, whether that's academics. So every day or like every week, your priorities will change, but it's more about being strategic about what you're prioritizing every day. And that's really how you can manage your time and also balance your life as well. Like my social life is fine, my academic life is fine, my business life is fine, my health is fine as well. So making sure that you understand what you want to prioritize each day. Um, okay. Other tips, let's see. What was your trick to being so successful? That's so nice that you think I'm successful. I will say whenever it comes to my mindset, I have I've adopted pretty much a really growth mindset as well, and also just like believing in yourself. I think that is the main thing. And I will say, like, whenever it comes to motivation and discipline, discipline will always outpower motivation. Why is that? In order to be successful, you have to be consistent. And motivation is inconsistent. So if you're relying on motivation, then that is hindering your journey to success. You'll need to rely on discipline. And of course, if the motivation is there, that will be that boost to the discipline, but you do need to rely on your discipline. In addition to that, you need to understand like you want to be purpose driven. So for me, I feel like a lot of my purpose comes from helping people. So that's like, for example, that's why I'm doing this presentation to help you guys in some way. So a lot of my purpose comes from helping people. So that's why I grew Ultimate Ivy League Guide, for example, right? Because I wanted to empower students. I wanted to empower them to become the next generation of leaders. And then that's also why I do science. That's also why I do research, right? Because I want to help people. I want to use my knowledge to help people in some way. Okay. Um, okay. What would be some tips that would help high school juniors in future whenever it comes to applying to colleges? Yeah, if you follow my Instagram, I'm gonna push out a bunch of videos soon regarding like what you should be doing as a high school junior. But essentially, like one thing that I would begin thinking about pretty early is who you want your teacher letters of recommendation to be. Because if you can identify or at least think about that early, then you can form closer connections with your teachers earlier on. You want at least one academic recommender and one personal character recommender. And this is advice for rising seniors as well. Whenever it does come to the college application, you want one academic recommender, one personal character recommender. And the reason why is if you like if you tell both of your recommenders the exact same thing, they're going to have the exact same recommendation letter. So then whenever an admission officer reads that, they're going to see a copycat recommendation letter, and that's not necessarily going to showcase various facets of your profile. So if you have one person that really focuses on your academic capabilities and another person that focuses on your personal qualities, and that way you will provide a more multifaceted presentation of yourself to the admission officer. And then of course, communicating that value-based theme that I talked about earlier. Okay. Um, okay. How do we bounce back and stay determined after facing failures and setbacks? Yeah, definitely. I think this is a big question that a lot of students ask, and this is something that I've reflected upon in my life as well. So, I've also gone through various failures in my life and various setbacks in my life, whether that's personal challenges, academic challenges, etc. I would say that with every single failure or setback that you encounter, that moves you forward in the right direction, right? So I see all of my failures and all of my setbacks literally as an opportunity for me to grow. And one thing that I have adopted with my mindset that has also helped me is I don't let my past or I don't let my failures define who I am, or I don't use them as excuses to explain my present moment. So let's say like I failed in some way, I don't use that as like, oh, this is why I am the way I am. What I really do is I'm like, okay, that was my past. What can I actually do to move forward? So I always look at the action item. So rather than really being attached to my past failures, what I think about is like, okay, this is my current situation. This is where I want to be. What are the steps I need to take to get there? And that's exactly how I move forward in life. Um, yeah. Okay, let's see. There's so many questions. Okay. Um, what are some ways you found research slash internships while in undergrad? So if you are in your undergraduate years right now, your school is probably hosting career fairs. So look into, your career office if they have something like that. That is probably where you'll find like career fairs or resources. I just attended a bunch of these fairs and just talked to people and kind of just pitched myself in some way. Also cold emailing people, I did that as well. So I shared a cold email template earlier that you can definitely use. Yeah. Okay. Okay. Is it rude to ask teachers to focus on specific things such as your academic or characters for letters of recommendation? No, not necessarily. So whenever it comes to asking your teachers for a letter of recommendation, what you want to provide for them is what really term a letter of specific instances, which is, really detailed reflections or like reminding them of really detailed moments that they can include in the recommendation letter. So let's say that you are approaching your personal character recommender and you want them to really highlight your values of community service. So then in that sense, you can provide them with a bullet point list of times in which you have initiated community projects, times in which you have helped people, maybe you put together some study groups for your peers, and you want them to mention those. So, but by providing them that list of specific instances, it will not only make the writing process easier for them, right? Because then they can literally just like use the examples that you gave them, but it will also make sure that your letter of recommendation is extremely specific. So it's clear to that admission officer that that the teacher didn't just like copy and paste the same letter of recommendation template between you and another student. Okay. Um, okay, I'm gonna answer one more question because I think I'm losing my voice. But can you give more interview tips? Yeah, so what I would actually do, go watch my interview video on my YouTube. It actually walks you through the entire interview process. It's like a 30-minute video. Watch it. I'm sure it will help you a lot. But essentially, whenever it does come to answering interview questions, I would apply the same key framework that I ask students to apply to their essays, which is the PPF framework, the past, present, future framework. So if an interviewer asks you about like, what is your passion, right? Then you want to tell them how your passion developed. Then you want to, which is the past component. Then you want to tell them how you have currently tried to pursue your passion, which is the present component. And then you want to tell them how you see yourself pursuing your passion in the future, which is that future component. So always having a story would is a really compelling way of answering all of these questions. So if they ask you about an extracurricular that you're doing, make sure that you know what your top one or two extracurriculars are. And rather than just like bullet pointing, like, oh, these are all the things I've done in my extracurricular, give them a story, right? People love hearing stories. If they hear a story, they'll be able to remember it better. And in that way, whenever they write up your interview report, it'll be a lot more specific. So if you're talking about an extracurricular, give them a story of like how you became passionate about the extracurricular, how you got involved, what have you done, and then how do you see it moving forward in the future? Yeah, okay. So I think that is all the questions I'm going to answer. Hopefully that was helpful. Again, if you want to connect with me or learn more about the college application process, definitely recommend following me on Instagram. That's where I'm most active. YouTube as well. I also post on there, and of course TikTok, and then LinkedIn is where I'll post a little bit more about my personal like publications or things like that. Okay. Hopefully that was
Oh,
helpful.
thank you so much, Elise. That was such an informative presentation. And like she mentioned, definitely don't hesitate to reach out and connect with any of your platforms. So just before you head off, a little tradition we have here is to give our guest speakers a virtual round of applause. So if everybody could tap the react button and hit the clap emoji, that would be amazing. Thank you so much, Elise. We definitely appreciate it.
Thank you so much, guys. Hopefully that was really helpful. I love helping students. So yeah, continue to connect with me and hopefully I can see some of your faces more in the future. Thank you.
Awesome. Okay, so I'm just going to launch our first poll for attendance today. So I'll give you guys a few minutes to answer that one while I set up our presentation. Yeah, so there are two polls in each session. The second one should be released either during the workshop or afterwards. All right, and just to confirm, can you guys type in the chat if you can see my screen? Amazing. Awesome. So we can get started. As you can see by the title of our slideshow, today's workshop is going to focus on genetics. And also, welcome to our fifth session of our summer national program. It's crazy that we're almost coming to an end, but I can't wait to get started. So, to go over the agenda of today's workshop, sorry, I'm just seeing a message in the chat. If you did miss the poll, just feel free to send a message to Rourke on Slack, and he'll let you know what the next steps are. Okay, so for today's workshop, we are going to take a look at the history and some major milestones that went into discovering DNA as the genetic material. And through this process, we're also going to analyze the structure of DNA. From there, we're going to look at the process of DNA replication and then understand how information flows from a gene to a protein. And so in this section, we're going to focus on the two processes, transcription and translation. And we'll finish off with exploring how gene expression is regulated. Okay, so in the early 20th century, the big question that biologists everywhere were really struggling to answer was, what is the molecule of inheritance? And the proof that DNA was the carrier of genetic information evolved a number of historical experiments. So let's go over a few of them. Starting off in 1860, so Gregor Mendel worked with pea plants and he discovered that genes actually come in pairs and they're inherited as distinct units.
فهو المحاضرة اتقفلت مرة واحدة لما أنت رنيت فراح ما جالكش السؤال بقى. فهو السؤال ما جاليش السؤال اللي هم بيسألوه. أنا حضرت أول ساعة
Just a reminder.
هيجابوني على السؤال ده هيجابوني ليه؟ ما كده كده السؤال اللي هو السؤال ده هيعملوا إيه؟ ما فيش حد فيها ليه؟
You're muted. We can't hear you.
All right, can you guys hear me now?
Yeah, still can't hear you.
Okay, so sorry about that, guys. Give me a second. Let me pull up the chat again. The good thing is I didn't go over too much yet, so it should be good.
Can hear you now.
Perfect. Okay. So let me just go back. Welcome everybody to our fifth national session of our summer program. I can't believe that we've already made it. We're nearing the end of our program, but I'm so excited to get started. And today's workshop is going to be on genetics. So just a quick agenda for today. First, we're going to take a look at the history of DNA discovery and explore some of the major milestones. Then we're going to look at the structure of DNA, as well as the process of DNA replication. From there, we are going to take a look at gene expression and how information flows from a gene to protein. And last but not least, we will take a look at how gene expression is regulated in both prokaryotes and eukaryotes. All right. So in the
Can I ask you something?
yes, go ahead.
DNA is summary of what? And
Sorry, could you repeat that question?
what does mean DNA?
So
DNA,
we're going
what
to
does it mean?
Yeah, so DNA is the carrier of genetic information. And we'll talk a little bit more about it during the presentation so that you can get a better understanding. Okay.
Okay, I get it. Thanks a lot.
Sorry?
Okay, I get it. Thanks a lot.
Okay, no problem. All right. So in the early 20th century, the big question that biologists were struggling to answer was what is the molecule of inheritance? And the proof that DNA was the carrier of genetic information involved a number of different historical experiments. So we're going to take a look at a few of the key players in the discovery of DNA. Okay, so starting off in 1860, Gregor Mendel was the first person to propose the idea of genes. So he worked with pea plants and he was able to discover that genes actually come in pairs and they're inherited as distinct units, one from each parent. Then in 1869, Frederick Miescher discovered what he called at the time nuclein, but we now know that as DNA. And so he actually isolated DNA molecules from white blood cells that he collected from pus on bandages. Then in the early 1900s, Phoebus Levine identified DNA and RNA as separate molecules of nucleic acid. And he's most known for his hypothesis that DNA is made up of equal amounts of adenine, guanine, cytosine, and thymine, which are all nitrogenous bases that make up DNA. And then in 1910, Morgan discovered that genes are located on chromosomes. And so because the two components of chromosomes are DNA and protein, these two components became candidates for genetic material. And so now we're going to take a look at a few of the major experiments that led to the discovery of DNA as the genetic substance. Just give me a second. I'm just trying to open up the chat here so I can answer any questions as we go through. Perfect. Okay, so in 1928, Griffith discovered that a trait could be passed on from one cell to another by a process that he called transformation. And so In his experiment, he experimented with two different strains of a bacterium, one of which was pathogenic, meaning it was harmful, and the other bacterium was harmless. And after injecting both of these bacterium into mice, these were the results. So when living pathogenic cells were injected into a mouse, the mouse died. When living harmless cells were injected into the mouse, it resulted in a healthy mouse. When dead pathogenic cells were injected into the mouse was still healthy. But what was most interesting was that when he combined the dead pathogenic cells with living non-pathogenic cells, it resulted in a dead mouse. And a blood sample taken found that the mouse actually contained living pathogenic cells. And so from this, Griffith was able to conclude that the non-pathogenic bacteria must have taken up some sort of transforming principle from the harmful bacteria, that allowed it to transform into a pathogenic bacteria. And with this discovery, the race to identify the transforming principle began. So that leads us to 1944, when Avery, McCarty, and McLeod discovered that the transforming principle must be DNA. So in their experiment, they originally had a sample that contained the dead pathogenic cells, and that's this red one here. And then they split the sample into 5 different test tubes, each of which had an enzyme that degraded a different macromolecule. So for example, RNAs degraded RNA, this one degraded protein, this one degraded DNA, this one degraded lipids, and this one degraded carbohydrates. And so after these samples were added to a culture of harmless bacteria, the results that he found were that all of these samples produced harmful living pathogenic cells, except for the sample containing the DNA enzymes. And this was because the DNA enzyme degraded the DNA, meaning that there was no transforming principle to allow pathogenic bacteria to form. And so, although they did identify this, unfortunately, there was just so little information known about DNA at the time that no one believed them. And a little fun fact was that Avery was actually nominated for the Nobel Peace Prize 11 different years, but never won even once. And so in 1952, Hershey and Chase came, and they essentially just confirmed that the transforming principle really was DNA. And so in their experiment, they worked with bacteriophage, as you can see in this diagram, which are essentially just viruses that can attach to bacteria and inject a substance. So the question they were trying to answer was the injected genetic material DNA or protein? So they had 2 different batches of the phage. One batch, shown in pink, was grown in radioactive protein, and the other batch was grown in radioactive DNA. And so after these samples were spun in a centrifuge, as you can see in the second batch with radioactive DNA, the bottom of the test tube containing the bacteria was radioactive, which meant that the DNA is what was injected into bacteria. But in the first batch with radioactive protein, only the top of the test tube was radioactive, which contained the remnants of the phage. And so this meant that the protein was not injected into the bacteria. And so again, they just confirmed that the genetic material was DNA. And so Chargaff in 1950 discovered that there's an equal number of adenine and thymine bases and an equal number of cytosine and guanine bases. And this discovery was crucial in Watson and Crick's model, which we'll explore soon. So it's time for a little question. If a DNA sample has 33% adenine, how much thymine will it have? Option A, 33%, B, 17%, C, 67%, or D, 34%. Awesome. So I'm seeing a lot of option A's. And the reason it's 33% is because adenine and thymine base pair together. So they are present in the same amount. Now, if a DNA sample has 33% adenine, how much guanine will it have? This is a little bit trickier. Okay, so good job. I'm seeing a lot of the right answers in the chat. So the answer is 17%. And in order to understand this, don't worry, it is a little bit confusing, but there's some math that goes into it. So because we know that adenine and thymine each compose 33% of the DNA, if we add those together, we get 33 plus 33 is 66. And so what we're left with is 34% because 100 minus 66 is 34. And this 34 is divided equally into the cytosine and thymine bases. So since 34 divided by 2 is 17, it will have 17% guanine. Okay, so moving on to Watson and Crick. They essentially published a paper on the structure of DNA, but their original model wasn't always correct. So at first, Watson and Crick thought that bases paired like with like. So they thought that adenine paired with adenine, thymine paired with thymine. But as you can see in this diagram, so our purines here are the bases A and G, and our pyrimidines here are C, U, and T. But when two purines combine, we find that they're too wide. And when two pyrimidines combine, it's too narrow. So through Rosalind Franklin's discovery, she was a scientist who used a technique called X-ray crystallography to actually produce a picture of DNA. And from this picture, she was able to conclude that DNA was made of a sugar phosphate backbone that were linked together by covalent bonds here in the yellow. She also noted that within the DNA molecule, since there's two different strands, they ran anti-parallel. So what that means is that this strand here runs from the 5' end to what we call the 3' end, and the opposite strand runs in the opposite direction. So this one runs from the 3' end to the 5' end. And she also noted that the nitrogenous bases base pair in the interior of the DNA molecule. And so it said that Watson and Crick actually used stolen images from Rosalind Franklin in order to make their model. And what was most notable about what they said, they suggested that the specific base pairing, so adenine base pairs with thymine and cytosine base pairs with guanine, suggested a possible copying mechanism for genetic material. So since the two strands of DNA are complementary, each strand alone can actually act as a template for building a new strand in replication. And I'm just seeing in the chat, fun fact, tomorrow is Rosalind Franklin's birthday. Amazing. Okay, so Watson and Crick's semi-conservative model of replication predicts that when a double helix replicates, each of the daughter molecules will have one old strand, which is the dark blue strand, and one new strand, which is the light blue strand. However, at the time, there were competing models, one of which was the conservative model. So after the DNA molecule replicated, the two parent strands joined back together, as you can see over here. The two dark strands are together, while the two new daughter strands are together. And another competing model was the dispersive model. And this model suggested that each DNA molecule after replicating is a mix of both the old and new strands. And so Messelson and Stahl conducted a very important experiment in 1958 to prove that DNA replication is semi-conservative. Okay, so in their experiment, they grew E. coli in a sample containing heavy nitrogen. And then this sample was transferred to a medium containing light nitrogen, where the bacteria was allowed to replicate for several generations. And so what they found in the results was that, so in the original DNA, after spinning it in a centrifuge, in the test tube, they saw a band, a single band at the bottom, which corresponded to the heavy nitrogen. And the basis of this is that, heavier things sink to the bottom. So bacteria containing DNA with the light nitrogen is at the top, and the heavy nitrogen is at the bottom. But then in the first round of replication, they found a single band that was intermediate between the light layer and the heavy layer. And so this eliminated the conservative model, because as you can see in the conservative model, we have a strand containing just heavy nitrogen and a strand containing just light nitrogen. So had the conservative model been true, instead of seeing just a band in the middle right here, we would have seen a band at the bottom for the heavy layer and a band at the top for the light layer. And then, so that eliminated the conservative model. And then in the second round of replication, they found again a single intermediate band, but also a band in the top layer. And so this eliminated the dispersive model, because the dispersive model suggests that after replicating, the DNA is made up of a mix of both the old and new strands. So we would have seen just one single band in the middle had the dispersive model been true. But because we have this top layer from the new daughter strands that are just made up of light nitrogen, this proved that DNA replication is semi-conservative. Okay, so now that we've gone through sort of like the history behind the discovery of DNA and DNA replication being semi-conservative, we're going to deep dive a bit into the process of DNA replication. But before we do that, we have a little activity for you. So in a few seconds, there's going to be about 20 letters on the screen. And I want you guys, without hitting Control C and Control V, to type the letters as fast as you can into the chat. 3, 2, 1, go. Okay, so I'm seeing everybody pop up these letters in the chat. Not gonna lie, that was pretty fast. But what you'll find most astonishing is that our cells can copy this in 0.025 seconds. And it just goes to show that DNA replication is remarkably fast and also remarkably accurate with only very few errors. In fact, an interesting statistic is that our cells can copy 5 billion nucleotide pairs in just a few hours. And so since the two strands in the DNA molecule are complementary, as I mentioned before, each of the strands can act as a template for building the new strand. And so in DNA replication, the basic process is that the parent molecule is able to unzip and two new daughter strands are built using base pairing rules. So the first step in DNA replication is initiation. And replication begins at special sites called origins of replications, which are these black dots over here. And so at the origins of replication is where the two DNA strands begin to separate and they open up a replication bubble. So prokaryotes, because they have circular chromosomes, they only have one single origin. But eukaryotes like us can have up to like hundreds of thousands of origin sites in order to speed up the replication process. And so in this replication bubble, you'll notice that it replicates in both directions. So on the left side and on the right side until the entire molecule is copied. At the end of each of these replication bubbles is a Y-shaped region called a replication fork. And this is where the DNA strands are elongating. All right, so now we're going to take a look at some important enzymes that help in the process of replication. So starting off with helicase. Helicase is this green enzyme right here, and its job is to unzip the double helix at the replication forks. Once the two parental strands separate, single strand binding proteins come into play. And their job is to prevent the two parent strands from sticking back together again. But unfortunately, so we have two strands that are twisted together in a double helix structure. As we keep untwisting and untwisting, this causes even more twisting ahead of the replication fork. And in order to correct this, we have an enzyme called topoisomerase, and its job is to cut, rotate, and stick the strands back together again so that they're not too twisted together. And that would be the blue enzyme right over here. Okay, so the next step in DNA replication is elongation. So now that the two template strands have separated, they are now able to serve as a template to create new complementary DNA strands. So DNA polymerase is an enzyme that catalyzes the elongation of new DNA. But the catch here is that DNA polymerase can't initiate synthesis. It can only add on nucleotides to an already existing chain. So that's when the primer comes in. The primer is the initial nucleotide strand that's made up of RNA. And that's the green strand over here in this diagram. And primase is the enzyme that makes this initial primer. All right, so now we're going to look at a concept called anti-parallel elongation. So since DNA polymerase can only add nucleotides to the 3' end of a daughter strand, the new DNA strand can only be written in the 5 to 3' direction. And a little rhyme to remember that is 5 to 3 like a tree. So looking at this pink strand at the top here, this is called the leading strand. So along one template strand of DNA, the DNA polymerase synthesizes a leading strand continuously moving towards the replication fork. So as the replication fork is untwisting in this direction, so towards the right, because this daughter strand is in the 5 to 3' direction, it can add nucleotides in the same direction that the fork is moving in. But a problem arises in the bottom daughter strand. So this is called the lagging strand. And in order to elongate this, the DNA polymerase must work in the direction away from the replication fork. And the reason being is you'll notice the order here goes from 3' to 5'. But DNA polymerase can only add nucleotides to the 3' end of it can only add nucleotides to the 3' end, meaning that it's working in the opposite direction. And this creates gaps in between segments that we call Okazaki fragments. And these fragments are eventually joined together by DNA ligase. So I know this concept is a little bit difficult to understand without an animation. So we're just going to take a look at a quick snippet from a video, and this one is none other than from the Amoeba sisters.
In this image, I labeled the top original strand 3' to 5'. I labeled this bottom original strand 5' to 3'. That's the original DNA that is going to be replicated. DNA is unwinding here thanks to helicase, In this example, it will keep unwinding in this direction. Primase places primers. DNA polymerase is building the new strand. Now, the thing about DNA polymerase is when it's building a new strand, it can only build the new strand in the 5' to 3' direction, meaning it adds new bases to the 3' end on the new strand. See how it's being built in the 5' to 3' direction? This one is called the leading strand. But take a look down here. So DNA polymerase, once again, is building a new strand in the 5' to 3' direction. But there's a bit of a problem here. See, as DNA unwinds, because DNA polymerase can only build the new strand in the 5' to 3' direction, it has to keep racing up here next to where this unwinding is happening. You can see why then this new strand is known as the lagging strand. On this lagging strand, primers have to keep being placed in order for DNA polymerase to build. These fragments that result are known as Okazaki fragments. Primers have to get replaced with DNA bases since the primers were made of RNA. Ligase, the gluing enzyme, as I like to nickname it, has to take care of the gaps between Okazaki fragments, sealing them together. At the end of replicating, you have two.
Awesome. Okay, and so this diagram is just taking a look at the lagging strand in detail. So as you can see, these Okazaki fragments keep having to race up to where the replication fork is unwinding, which is towards the left. And this diagram basically just summarizes all the different enzymes that are involved in the process of replication. So it is time for a little game of matching the enzymes to their functions. So on the left here, I have a series of different enzymes, and we're just going to go one by one, matching them to the correct function. So starting off with ligase, I'll give you a second to read the different functions over here, and you guys are going to tell me what number corresponds to ligase. Awesome, yeah, so ligase joins Okazaki fragments together, topoisomerase. Yes, I'm seeing a lot of 4. So topoisomerase relieves strain from overwinding. DNA polymerase 3. Yeah, so DNA polymerase 3 adds nucleotides to the 3' end of a growing strand. Primase. Okay, I'm noticing we might be missing one from here. But yeah, so primase makes a short fragment of RNA. Oops. Helicase. Okay, so I think helicase might be missing, but for the single strand binding protein. Yes, a single strand binding protein prevents separated strands from combining back together. There we go, there's number 6. All right, so now we're going to take a look at telomeres. So if you were to zoom in and look at the DNA on the tip of one of your chromosomes, you would see a single sequence, TTA, GGGGG, repeated over and over again, hundreds to thousands of times. And these repeated nucleotide sequences are called telomeres. And telomeres do not contain genes. So you may be wondering, what is the purpose of them? The purpose of telomeres is to postpone the shortening of chromosomes. So taking a look at this diagram here, as DNA replication comes to the end of the DNA strand, as I mentioned before, DNA polymerase can only add to the 3' end of an existing strand. And because there's no 3' end over here, some of the DNA at the end of the chromosomes can't be copied. And so that's why telomeres are here. Although they don't prevent genes from eroding at all, they do postpone it. Although there does come a point where even the telomeres become too short, which is why cells can't divide forever. And the shortening of telomeres might actually protect cells from cancerous growth by limiting the number of cell divisions. Now, if chromosomes of germ cells become shorter, there are a lot of essential genes that would be missing from the gametes they produce. And in order to combat this, an enzyme called telomerase is able to catalyze the lengthening of telomeres, specifically in germ cells. And there's actually evidence that there's evidence of telomerase activity in cancer cells, which may be a reason for why cancer cells are able to persist. Okay, so moving on to taking a look at how the information in genes is able to code for a protein. So the big idea that I want you to understand here is that DNA is how the information for life is stored, while proteins are what actually do the work of life. And so gene expression is a process by which DNA directs protein synthesis. But before we get started, I want you guys to type into the chat the answer to what is a gene? What is the first thing you think of when I say gene? DNA, a segment of DNA. It makes a phenotype. Yeah, so some answers that you might be thinking of, a gene could be a specific location on a chromosome. It could be a specific nucleotide sequence along the length of a DNA molecule. And even with all the answers I'm seeing in the chat, these are all definitely right? But we'll see later on that they're definitely an oversimplification of what genes actually are. So after looking through the process of gene expression, we're going to revisit the definition of what a gene truly is. So the central dogma is a concept that cells are governed by a cellular chain of command, starting with DNA, which is then transcribed into RNA, which is then translated into a protein. So there are two main processes in gene expression, the first being transcription. So since DNA and RNA are written in different forms of the same language, the information can simply be transcribed. And so DNA is used as a template to assemble an RNA molecule in the process of replication. And the type of RNA that's created is referred to as messenger RNA because it carries a genetic message from DNA in the nucleus to ribosomes in the cytoplasm. And the second step is translation. And this is when a protein is made using information in the mRNA. And the site of translation is ribosomes, which we'll take a closer look at later. So there are 20 different amino acids, but only 4 nucleotide bases in DNA. So you may be wondering how many bases correspond to an amino acid. Well, in mRNA, every 3 nucleotides is called a codon, which you can see over here. And each codon specifies for a specific amino acid. So out of the 64 different codons, 61 code for amino acids, while the remaining 3 are stop signals that end translation. And so another big idea here is that although genetic code is redundant, so for example, multiple different codons can code for the same amino acid, genetic code is not ambiguous. So one codon will never code for multiple different amino acids. Okay, so now we're going to take a closer look at transcription. So As I said before, RNA synthesis is catalyzed by RNA polymerase, which pries the two DNA strands apart and adds nucleotides to the 3' end. It follows the same base pairing rules as DNA, except uracil now is substituted for thymine. So a couple different key terms here. A promoter is the green section here, and this is the DNA sequence where RNA polymerase is able to attach. And RNA polymerase is the gray figure you see here. And a transcription unit is the stretch of DNA that is being described. So there are three stages of transcription, starting off with initiation. Oops. So in initiation, a collection of proteins called transcription factors, which are the purple ones here, they first attach to the promoter, and this triggers RNA polymerase II to then bind to the DNA, and it begins transcription. So included in the promoter is what we call a Tata box. And it's called a Tata box because it's a series of T and A base pairs, and this is a weak spot on the DNA molecule for the RNA polymerase to attach to. Then in elongation, RNA polymerase, it moves along the DNA strand and it transcribes nucleotides. And lastly, in termination, so how it works in eukaryotes is that a specific signal sequence, once a specific signal sequence is transcribed, at a point downstream, proteins are actually able to cut the RNA transcript free from the polymerase. And then the RNA polymerase it continues transcription until it eventually falls off. Okay. So before this mRNA is dispatched into the cytoplasm, enzymes in the nucleus must modify the pre-mRNA in a process called RNA processing. And there are a couple things that happen here. One of which is the mRNA ends get altered. So as you can see in this diagram, the 5' end receives a modified nucleotide 5' cap, and the 3' end gets what we call a poly A tail. And so some of the functions that these serve are that they protect the mRNA from hydrolytic enzymes, and they also help export mRNA. Another modification process that happens is RNA splicing. So although the average length of a transcription unit is 27,000 nucleotide pairs, it only takes 12,000 nucleotides to code for an average size protein. And you may be wondering why. So the reason is because most eukaryotic genes, they have very long non-coding stretches of nucleotides. And these non-coding sequences are interspersed between the coding sequences. And so the sequence of DNA that codes for a protein is usually not continuous, and instead it's split into segments. So introns here these are the pink ones over here, are the non-coding segments, and exons in red are the coding segments. And they get their name because they are expressed and translated into amino acid sequences. So in RNA splicing, introns are removed, and then the exons are joined together. And this is carried out by a complex of proteins called spliceosomes. So you may be wondering, what purpose do introns serve? I mean, cells, they expend so much energy to copy the entire length of a DNA strand only to remove them. So there are two purposes of introns. One of them is that they act as a mutational buffer. So because introns occupy about 40% of the total length of genes, a lot of randomly occurring mutations fall into these regions. So they don't end up affecting the DNA strand. Another purpose of introns is that their need to be removed is what provides the opportunity to put mRNA back together in a variety of different ways. So one of these ways is called alternative splicing. So a single gene can code for multiple different proteins from just simply by using different combinations of exons in the same order. So for example, exon 1 and 2 can be combined, or exon 2 and 3 can be combined. Exon shuffling, on the other hand, is when the order of the exons are actually rearranged, and this results in the evolution of new proteins. So 3, 2, and 1 could be combined, or 2 and then 1 could be combined. All right, so moving on to translation. A cell is able to translate an mRNA message into proteins with the help of transfer RNA, or which is also called tRNA. And so tRNA basically acts as a translator. It reads a nucleic acid word, so the mRNA codon, and it interprets it as a protein word, which would be the amino acid. And no two tRNA molecules are the same. So each tRNA carries a specific amino acid on one end, which you can see in the gray. And each tRNA molecule also carries an anticodon in the dark green over here that base pairs with a complementary mRNA codon. So in order to accurately translate mRNA into protein, two conditions have to be met. The first is that a correct match between a tRNA and amino acid must be met, and there also must be a correct match between the tRNA anticodon and the mRNA codon. So if one tRNA existed for every mRNA codon specifying an amino acid, there would be 61 different tRNAs, but bacteria only have 45 tRNA. And the reason for this is that some tRNAs can actually bind to more than one codon because the third nucleotide base of a codon, which is generally U, can pair with either an A or a G. And this flexible base pairing is a concept called wobble. And this explains why synonymous codons for a specific amino acid differ in only the third nucleotide base. So for example, in all of these different codons that code for glycine, you'll notice that they're only different. It's only their third nucleotide base that's different. So tRNA with the anticodon UCU can base pair with two different mRNA codons, AGA and also AGG. And both of these codons eventually code for the same amino acid. Okay, so it's time for another question. What amino acid will be generated based on the following mRNA codon sequence? So I'll give you guys maybe like a minute, but what you're trying to do is match the codons. You're going to find the codons in these chart and match it to the amino acid that it codes for. And if that's too tricky, feel free to just find one of them. So maybe like the first few. All right, I see an answer in the chat. Give you guys maybe like 20 more seconds, and then we'll move on. Awesome. Okay. So good job to everyone. But here's the answer. It's honestly just a matter of finding these codons in the chart and then typing up the amino acid. Okay, so just like translation, actually, before we move on to that, as I mentioned before, translation happens at ribosomes, right? And so the specific pairing of the tRNA anticodons to the correct mRNA codon is facilitated by the ribosomes. And each ribosome has an mRNA binding site, which we see here on the bottom. And they also have 3 tRNA binding sites. And each of these binding sites has a name. So the P site holds the tRNA that carries the growing protein chain. Then the A site holds the tRNA that carries the next amino acid to be added to the protein. And lastly, the E site is the exit site, and this holds the empty tRNAs that will eventually be discharged. Okay, so just like transcription, there are 3 stages of translation. The first stage begins with initiation. So taking a look at the diagram, the image here at the top, first a tRNA enters the P site, and it carries an amino acid with it. And then another tRNA enters the A site, and so once the new tRNA enters, a peptide bond is formed in between the 2 neighboring amino acids. And once this bond is formed, it actually transfers the whole protein chain to the tRNA in the A site. Okay, and so this is elongation. And now I want you to imagine that the ribosome moves 1 codon forward. And when it moves along 1 forward, the tRNA that was originally in the A site, so the one with the purple protein chain, is now in the P site. And the tRNA in the P site now moves to the E site. Again, I know this is a little bit confusing without animations, but just try to visualize the ribosome moving 1 step forward. And so this empty tRNA is now removed because it doesn't carry any amino acids. And now the A site is ready to receive another tRNA with an amino acid. And this process keeps going on and on until an amino acid triggers the translation to be stopped. So this is would be one of the 3 stop codons that we looked at earlier. And at this point, the A site will accept a protein called a release factor. And instead of adding an amino acid, it adds a water molecule, which releases the protein. Okay, so mutations are changes in the genetic material of a cell or virus. And so a point mutation in specific is a small scale mutation. And this can lead to an altered mRNA or an abnormal protein. So there are 2 categories of mutations. The first is base pair substitutions, and the second are base pair insertions or deletions. So first, we're going to take a look at base pair substitutions. There are 3 different types. The first one is a silent mutation. And so in a silent mutation is when the substitution of 1 nucleotide has no effect on the encoded protein. So this will be a little easier to understand if we take a look at the diagram here. So the original mRNA codon is AAG. When we simply substitute this 3rd nucleotide for an A, it still codes for the same amino acid. Hence the name silent mutation, because it doesn't have an effect. Now, a missense mutation is when the substitution causes 1 amino acid to change into another. So here we have AAG. If we substitute this A, sorry, I'm just trying to find my mouse here, my cursor. So if we substitute this A here for a G, now we have an mRNA codon that codes for a different amino acid. And so it gets the name missense because it still codes for an amino acid. So it makes sense. It just doesn't make the right sense. And so the last substitution is called a nonsense mutation. And this is when the substitution changes a codon into a stop codon. And when this happens, translation is terminated prematurely, and it results in a shortened non-functional protein. Okay, and we also have base pair insertions or deletions. So compared to the substitutions, these guys are far more disastrous. And in order to understand this, we kind of have to take a look at reading frames. So if you take a look at the diagram to the left here. So we have a sentence grouped with, we have a sentence made up of 3-letter words. So it says the fat cat sat. But the moment we delete just one letter, if we were to group these again into 3 letters, this new sentence makes absolutely no sense. And that's exactly what happens when we delete, when the number of nucleotides we add or delete is not a multiple of 3. The entire reading frame shifts. And so following the insertion or deletion, all of the amino acids would be incorrect. But what you'll notice is that if we add or delete 3 nucleotides or multiple of 3 nucleotides, so if we were to remove the 3 letters here, you'll notice that if we group this sentence into 3 letters, we still get the cat sat, which is a sentence that makes sense. So it only causes a problem when the number of nucleotides isn't a multiple of 3. And so this brings our next question. Which small-scale mutation would be most likely to have a catastrophic effect on the functioning of a protein? A base substitution, B, a base deletion near the start of a gene, C, a base deletion near the end of the coding sequence, but not in the terminator codon, or D, a deletion of 3 bases near the start of the coding sequence. Awesome. So I'm seeing a lot of B's in the chat. And I'm just going to go over some of the key words that you want to look at. The first one says a base substitution. And as we just learned, substitutions are not as harmful compared to deletions or insertions. The key in the answer was that it was not a multiple of 3 for the nucleotides that were added, and it happened at the start of the gene. Whereas in C, the deletion happened near the end of the coding sequence. So prior to that deletion, all of the amino acids were correct. And then in the last one, it was a deletion of 3 bases. So all of the amino acids were correct. It was simply just missing one. Okay, and so I know we're almost reaching the end of our session. So I am just going to wrap it up with mutagens, and then we're going to revisit what it means to be a gene. Okay, so mutagens are physical, chemical, or biological agents that can cause these mutations that we just talked about. So some examples are X-ray radiation, UV radiation, a lot of the carcinogens like cigarette smoke. There are a number of different mutagens that exist. Okay, so going back to what a gene is. Simply saying that a gene is a DNA sequence that codes for a protein is an oversimplification because, as we learn, a lot of eukaryotic genes contain non-coding segments called introns, and they take up such a large portion of our genes, but they do not correspond to proteins. Furthermore, there are things like promoters that exist in DNA that are also included because without them, transcription wouldn't occur. The definition of a gene also has to be broad enough to include DNA that's transcribed into tRNA and other RNAs that aren't translated. So when we combine all of these ideas together, a gene is a region of DNA that can be expressed to produce a final functional product that is either a polypeptide or an RNA molecule. All right, so I am going to wrap it up at that just because we're nearing 7 o'clock. The remainder of the presentation will be posted, but we're just going to be taking a look at how gene expression is regulated in prokaryotes, so using the operon model. And there's two different types of negative gene regulation. Again, they'll be posted. I know we weren't able to get through it, but I'm just gonna go through some of these. And then in eukaryotes, there are a number of different processes that also regulate gene and these take place all the way from the beginning prior to transcription to post-translation. All right, so thank you so much to everyone for joining and tuning into the fifth national session of our summer program. Just a few reminders before you guys leave. Actually, we are going to launch the poll right now. So let me do that right now. But a few reminders is that we will be taking our group picture on the Friday. So all you guys have to do is just turn your camera on for like 30 seconds. So we're just giving you a heads up in case, just so that you're prepared to do this. And also we'll be releasing the prompt for our research symposium on Friday, which will be exciting. And any other resources like program homework will also be released on the Friday. So that wraps up our presentation. Let me just launch the second poll. And once you guys have answered the poll, you are free to exit the meeting. Thank you so much to everyone for joining, and we can't wait to see you all on Friday.
I have a question.
Yeah.
What is a research symposium?
Yeah, so the research symposium, it's essentially an opportunity for you guys to take on a research project. So for every program, we always have a prompt. And from that prompt, you guys will have like a lot of creative freedom, I guess, or freedom to choose what topic you want to research in order to solve a specific problem. And on Friday, we'll definitely provide more details and you will get the actual prompt itself. So we'll give you more information on how to go about starting your project. And if you want to collaborate with other members, we can also get you guys connected.
Okay, thank you.
No problem.
We also have another question,
Yeah.
if that's okay. I missed the first poll and work hasn't replied to my messages yet. So do you know what my next steps are for?
Yeah, for sure. Honestly, I think he just might be flooded with a lot of messages right now.
Okay.
So even if he hasn't gotten back to you, maybe just shoot him another message if it's been over like 48 hours. But yeah, don't worry, he will get to you eventually.
Okay, thank you.
No problem.
Can I ask a question?
Yeah.
So will be a problem if I like attend the national session instead of the international one on Friday?
No, so that's great that you came and joined in for the national session. It shouldn't affect your attendance, but again, just let Vork know in advance so that he is aware of that.
Hi.
Okay,
So
thank you.
Sorry. I was wondering, so once the national session is over for next year, would there be an opportunity to be on the leadership board for MedStamp, or how does that work?
Yeah, for sure. So I think Davina can speak more on that on Friday. But we usually discuss more about that on the last session. And she might be sending out applications or at least information on when applications will be releasing. But yeah, there's definitely opportunities to get on board.
All right, awesome. Thank you.
No problem. All right, so if no one else has any